Okay. Oh, I see what I did. I did it different right here. So let's just go with this way that I'm saying right here now. Let's go to the question. Rotate clockwise. I updated my Adobe and for some reason I'm having difficulty with the new features. So just give me a second. This is the question, right?
Number 1, the conjugate complex number.
All right, so
Sir, I'm not seeing it.
we're just looking at question 23. You're not seeing it?
No,
Oh,
sir.
I'm on. Okay. Seeing it now?
Yes, sir.
All right, so this is question 23. And what they want is the r plus 1 term, right? So you didn't even need to do what I was doing right there. You just want the r plus 1 term. All right, so you don't need to do all of this based off what they were doing. You just want the r plus 1 term, right? So you have to just follow the trend. Let's follow the trend. So the first term, so if I was asking you in general for SR, SR would just be up to the rth term, right? The sum up to the rth term, which should be 2 to the 0 minus 2 to the 1 plus 2 squared. But the thing is, we want to identify now which one is going to be associated with negative and which one is going to be associated with positive. All right, that's what we want to do. Which one is going to be associated with negative and which one is going to be associated with positive. Now notice right here that when the number is even, which one is associated with even? The power is positive. The power is positive.
Yes,
so just to go back to the question, what we want to do is find the r plus 1 term. The r plus 1 term is what we want to find. And the r plus 1 term, I can tell you, is going to be a negative. And the reason why it's going to be negative is because the r term is going to be positive. All right, so right here, what I was pretty much doing was writing it, summarizing it to show that right here, what's happening is that when r is even, whenever the power is even, then it's going to form a part of the positive sum. Whenever r is odd, then it's going to be a part of the negative sum.
Okay.
To get that negative sum now, you pretty much just multiply it by minus 1. I don't know if that is making sense. T said that makes sense?
Yes, sir.
All right, but what we're going to do is, what I'm going to do, I'm going to work it using the formula method that we would have been accustomed to in terms of writing Sn in terms of R. And when I write Sn in terms of R, then I can plug in n as r plus 1, and then you get the term for that. So I'm going to work it that way and send as well. But this was just by eyeballing. I like to call that technique eyeballing. Some questions you can just eyeball. All right. So now we're going to be starting with 2015 paper. We're going to go through 2015. All right. So question 1. It says, what is the conjugate of the complex number? What's the conjugate?
C.
Cat. Easy question. So we can just shade C. Easy question. All right. So that's question 1. Too easy. Question 2. It says the complex number Z is equal to the root of 3 plus I can be expressed as?
Dog.
How do you know it is dog? Explain why.
Alright, first things first, all the options are in the polar form, which
Okay.
is R times the cosine of theta plus I sine theta.
Very good.
So first you'd have to find the modulus R and then the theta, which is the argument.
Nice. So we need to find the modulus of Z, which is equal to R, and R is equal to the square root of
root 3 all square, which is just 3.
Plus 1 all square, and then we'll square root the whole thing, right?
3 plus 1, which is 4, root 4, which is 2.
2, very good. And then we'll find theta, where theta is equal to?
The tan inverse of 1 over root 3.
Tan inverse of 1 over root 3.
5 by 6.
Nice. And that you said is dog?
Yes, sir.
So that's dog. All right, not bad, not bad. Question 3. It says, given that cosine 2x is equal to 1 minus sine square x, then the integral from 0 to pi of sine square is equal to?
Then 2 sine square x will equal to 1 minus cosine 2x. And then you divide both sides by 2.
Very good. So as you said, rightfully said, make sine square the subject first. So this question, asking you for this, we make sine square the subject from this. So what he's virtually saying is that we can clearly see that 2 sine square x is equal to 1 minus cos 2x. 1 minus cos 2x. Now, this question don't have x. It's not working with x, though. It's x over 4. So we can change this x to x over 4. And so this part, we can change it to x over 4 too. But then 2 times x over 4 is going to make this x over 2. And so therefore, now the integral of this side is going to be equal to the integral of this side. But notice that this has a 2 right here. So because this has a 2 right here, we have to now put a half. Times both sides by a half to get rid of this 2, put a half right here. So now we can evaluate the integral. So now we integrate 1. When we integrate 1, we just get x minus, when we integrate now, the 2 right here cancels 2 out of the 4 to leave x over 2. And when we integrate cosine, what do we get? We get sine. So we get sine x over 2, but we don't just get sine x over 2. Then we divide it by 2. Divide it by how much?
Wait, hold on, sir. Continue.
So when you integrate cosine x over 2, you get sine x over 2 divided by the differential of the x over 2, which is a half. They divide it by a half. And remember, we were multiplying a half on the outside. So you cannot just leave that, throw that half away. So we have to put back our half on the outside. Now we can simplify it. So now we can put our integrals, which were from 0 to pi. And so when we put in pi, right, the sine of pi over 2 is 1. 1 divided by a half. 1 divided by a half. What's 1 divided by a half? That's 2. So this is now equal to a half in bracket. We plug in pi, we're getting pi minus 2, close up that part, minus a half times, we'll plug in 0. We'll plug in 0, what are we getting? Plug in 0, we're getting 0 minus 0, which is just 0. So the final answer is a half,
pi
minus 1.
Oh.
Which
Wait,
is pi
sir.
by 2 minus 1.
In the integral bracket, sir, wouldn't you have like the integral of a half minus cosine 2x divided by 2?
In the integral bracket, I have a half.
A half minus cosine 2x over 2.
Why would you have cosine 2x?
Oh, I should replace the x with x over 4.
Yes. Remember that this was the key part. So this can trick a lot of persons right here. Right? They gave you with sine square x, and that's for cosine 2x, but then you're gonna have to replace the x with x over 4. So that's the trick. So this answer works out to just be pi by 2 minus 1. That's what that answer works out to be. Easy question, soft. All right, now this is a repeat question. I'm positive. 1 square root of 3 minus 4i. This is a repeat question. This is C. And the method I said to check it is, what you can do is just square it. So we write down 2 minus I. When you square 2 minus I, what you're going to get is 4 minus 4i plus I.
Wait, sir, repeat that.
Go again.
Can you repeat that, sir? I accidentally turned off the speaker.
Okay, I was saying the easy way to do these questions where they're going to ask you to find 1 square root of a complex number is to just square the answers that they give you, the options. Square the options. Instead of working out this long thing, you can just square the options.
If it was paper 2, you can work it out the longer way.
Yes, if it's a paper 2, but given it's paper 1, you just need to try the options that they give you.
That's a 4 minus.
And there's a trick to it. If they ask you for the square root of 3 minus 4i, always know that anyone that's going to have the square root of 3 is always out. So let's say I ask you for the square root of 5 plus 2i, right? If I ask you for the square root of 5 plus 2i, if you say an option with root 5, that option is already out.
What is a trick?
Yeah, well, it's not really a trick. It's just that we know that I square is going to be minus 1. And so if you square back this root 3, you're going to get 3. But then you're always going to have to either add I square or subtract I square. And so it wouldn't give you back the value of 3 when you square it. And so that's why I'm saying these two options are already out. But as I was saying, the easiest way to do this question is to just square these options. Just square them. You don't have time to be working it out the long way. And that's question 4. Easy stuff. Question 5 now, it is asking, or Rather, it says that the complex number z is equal to 1 over 1 minus I. To represent it on an Argand diagram, this is a repeat question.
Yes,
And
repeated.
this
You just
option,
find the model, the complex number, and then draw it on the Argand diagram.
yes, very good. So as we were saying, you have to multiply this by the conjugate of
By
the
the conjugate of
denominator.
the denominator.
So multiply it by 1 plus I, it becomes 1 plus I over 1 minus I times 1 plus I. That becomes 1 square plus 1 square, which is 2. And so 1 plus I over 2 is really a half plus a half I. And so the point, as a point, this is a half, a half.
So
The
a half
complex
on the
numbers
x.
can be written as a point. As a point, it is a half, a half.
So it's the
That's
first quadrant.
in the first quadrant.
As long as both of them are positive,
It's the first quadrant.
it's the first quadrant.
Yeah.
And if both of them are negative, on the second quadrant, on the fourth quadrant, I mean,
If both of them are negative, then
on the fourth quadrant,
that's the third quadrant. 1, 2, 3.
negative.
Yeah, if x
Oh
is
yeah, third
negative
quadrant,
and
third
y is
quadrant.
negative, that's the third quadrant. Yeah. So remember, we'll count quadrants this way, in the counterclockwise direction. All right. Question 6. Question 6 gives us f of x is equal to ln 2x. That's f of x. And you want to find f prime. So they just want you to differentiate it. Easy question. So it's now the differential is just equal to 2 over 2x. And 2 over 2x is just 1 over x.
x.
Easy question. Soft.
Soft with a capital T.
Exactly. This question now, they're asking for the equation. They're asking where this equation has a root. So if we're going to plug in 0, right, in this equation,
E
what
to
are you
the 0
going
is
to note?
1.
So if
And
you're to
0
plug
to
in
the
0, what we get?
E to the 0 is 1.
E to the 0 is 1. And so we're getting a number that's greater than 0. Because this is 1 minus 0, which is 1. So f of 0 is equal to 1, which is greater than 0. So now we need to check f of 1. F of 1 now would be equal to e to the 1 minus 1. E to the 1 minus 1. E to the 1 minus 1.
Yes,
That's
E, but
greater
E
than
is
0.
2.72 and 2.72 minus 1,
Which is
which
still
is
greater
greater
than
than
0.
0.
And
So
so
there's
there's no root right
no
here
root right there.
because this is IMVT, right? I don't know why this question is in module 1, but for some reason they put it in module 1. F of 2 now is going to be e square minus 2 to the 4th power, which is 16. Now e square is something like 2.7 square. That's roughly 5.6 point something. So 6
So I get
minus
negative, you know.
16 is less than 0. And so therefore the root lies on 1, 2. That's where the root lies. By IMVT, the root lies on 1, 2.
Okay, so that's fine. F of 0, F of 1, F of 2, F of 3, F of 4, and see which one the root lies.
That's that question. Too easy, soft. All right, now this question is asking for the number of bacteria present in a culture is modeled by y is equal to y naught plus e to the kt. And then they want the rate of growth c. So they don't call the rate of growth dy by dt, they call it c. And so when you're differentiating, you don't need to write dy by dt. You just need to say c is equal to, we differentiate this.
And
So
t equals 5. So
So let's differentiate this first. We differentiate this first. We have e to the kt. When you differentiate e to the kt, it's ke to the kt. And so we get k times y naught
e to the kt
times e to the kt. That's how we differentiate it. And then, as he said, they wanted it when t was equal to a particular value, when t is 5. And so we'll just replace t with 5. And so that looks like dog.
Yep, it's dog.
Replace t with 5. Easy question. It couldn't be any easier. Question 9. It wants you to differentiate ln x cubed. To differentiate ln x cubed, you bring down the power.
So it's 3 times the ln of x all squared multiplied by the derivative of ln x, which is 1 over x.
Very good. So we've carried on the power, subtract 1 from the power, then do what?
Multiplied by the derivative of ln x, which is 1
Very
over
good,
x.
which is 1 over x.
So the answer is cat.
Answer is cat. All right, nice. Remember what I said, if you're using an animal, if we're going to use animals, then we need to use animals for everything. And so, what's an animal that begins with A?
Ape.
Ape. A for
Yes,
ape.
sir.
So A for ape, B for bat, C for cat, and D for dog. All right, now that's consistent. All right, let's go. Now this question wants us to integrate this function right here. And we need to just evaluate this integral. But in order to evaluate this integral, we're going to have to use partial fraction, right? And the thing about this thing is that
Okay. They're equal to a over x plus b over x squared plus c over x minus 1.
come again?
So if I break it into partial fractions, it would be a over x
A over x
plus b over x squared
plus b over x squared, yes,
plus c over x minus 1
plus c over x minus 1. Oh, I can't go outside. I'm gonna have to go on whiteboard for that one. So it was 3 over x squared times x minus 1. And so that, as we were saying, we could break it up as 3 over x, not 3 over x, a over x.
a over x, yes sir.
And you said b over x squared?
Yes sir.
And then c over x minus 1. All right, that's not bad. And so now, what we're going to do is, if you're integrating this side, then you're integrating this side. And so if you're integrating a over x, that is just a ln x. Very good. You're integrating this now, integrating bx squared. Now, bx squared is really b times x to the minus 2. That can trip up a lot of people. Then when you're integrating bx to the minus 2, that is carry down the power. Say carry down the power.
No, so you add 1 to the power and divide by the new power.
Thank you, thank you. Sharp, sharp, sharp. I don't know why I'm differentiating a while ago. I just want to differentiate. So we add 1 to the power, and what we get? Bx to the minus 1, which is really b over x.
B over x.
Minus b over x plus
C times the ln
x minus
x
1.
minus 1.
And so that's what we're looking for.
So minus b of x could be written as minus b ln x, you know.
Repeat.
Minus b over x could also be written as minus b ln x, right?
Minus b over x can be written as?
Minus b ln x.
No, it cannot be written as minus b ln x. The differential of ln x is 1 over x. But 1 over x is not ln x. That's clear?
Oh, okay.
Yeah. So only when we differentiate ln x do we get 1 over x. All right. Now this question is asking for the integral of 1 over 1 minus sine square, but 1 minus sine square is cos square.
Cosine square x.
And then 1
1
over
over
cosine
cos
square,
secant square x.
secant square. So what they're
And if you
asking you to do
integrate
is,
secant square x, you get tan x.
so when you're integrating secant square, what we end up getting is tan x plus c. So that is option A. Easy question. Too easy, soft. All right. Question 12. Question 12 gives us a partial fraction, and they're asking how can we express it. So
P
first and
over
foremost,
2x
how many
plus 5.
denominators are we going to have?
3, because it's a
3.
repeated linear.
All right, because it's a repeated linear, and the repeated linear occurs right here, this x minus 1 all square. And so it's going to be 3 constants over each linear factor. So it's going to be a constant p over 2x plus 5, another constant q over x minus 1, plus another constant r over x minus 1 all square. That looks like dog.
Yep.
Easy question. All right. Question 13. Now, question 13 says a
Oh,
curve. Now, this is a
repeated, sir.
repeat. This is a
Cat.
repeat question. Cat is the answer. So all we do is define the derivative of y. The derivative of y is going to be 2t plus 2. We divide it by the derivative of x, which is 2t minus 2 from this. And then we'll factorize out the 2 and we'll get that. That's a repeat question. This seems to always come. This seems to always be there. Easy question.
14 is boy.
Question 14. It is?
Boy.
It is not boy, it is bat.
Bat.
We're dealing with animals. And so it is 1 over the square root of?
The square root of 1 minus 3x all square.
Very good. 1 minus 3x. 1 minus 3x all square. This 3x all square now, that's like your u. And so we need
Yes,
du.
sir.
Or du would be the differential of 3x is 3. So we can put a 3 right here and put a 1 over 3 out here. So now that we generate our derivative.
So you can preserve the function or the integration.
And so now what we end up getting is 1 over 3 times. Now this part is sine inverse.
Sine inverse.
Of 3x. And so indeed the answer is? Indeed the answer is but. All right, question 15. Question 15 asks us to find the argument of the complex number z. So how we find the argument
Tan
of the complex
inverse of
number?
root 3 over 2
Tan inverse of root 3 over 2
times
divided by
2. So it's basically the tan inverse of root 3, which is pi by 3.
Yeah, so just for clarity, it's root 3 over 2 being divided by a half. And when you divide root 3 over 2 by a half, that just gives us root 3. And so what we need is tan inverse of root 3. And tan inverse of root 3 is, what were you saying? Tan inverse of root 3 is?
Pi over 3, sir.
Pi over 3. Nice. And that's 15. That's module 1. Easy. Module 2 gets even easier. It says we want to find the sum from r equals 0 to infinity. So they want to find sum to infinity. Sum to infinity is a over 1 minus r. That's sum to infinity. Sum to infinity is a over 1 minus r. The first term is when we plug in 0 right here. When we put in 0 right here, we get 2n to the 0, which is 1. So the first term is 1 over 1 minus r. R is your common ratio. But here they tell you what the common ratio is. The common ratio is 2n. That's 2n. And so it's 1 over 1 minus 2n. That's boy. No, I can't say boy. We're dealing with animals. That is bat. Question 17. It says if the terms of the sequence u1, u2, u3, all the way, what is the nth term? They want the nth term. So again, to do this question, we look at the pattern that un plus 1 is we're pretty much adding 3 to each preceding term. Un plus 1 is un plus 3. And so if we were to change n to 2, then you're going to see that u2 is equal to u1 plus 3. And so what we're going to notice is then that u3 is going to be equal to u2 plus 3. u2 plus 3. But then again, u2 plus 3, but u2 is u1 plus 3. And so u3 works out to be u1 plus 2 times 3. That's going to be u3. Likewise, u4 is going to be equal to u1 plus 3 times 3. Catch a pattern. u2 is just u1 plus 1 times 3. u3 is u1 plus 2 times 3. u4 is u1 plus 3 times 3. And so finally, what we're going to get, I'm going to write it right here, is that we're going to get that un plus 1 is going to be equal to u1 plus some number. Which number it's going to be? When we had 4 right here, the number that went here was 3. And so n plus 1 right here, the number that goes here is n. It's n times 3. And that would be un plus 1. But now the question is asking for the nth term, which is un. So un is u1 plus n minus 1 times 3. So we're looking for 3 times n minus 1. That's un, which is A. A for ape. All right, question 18. Question 18 says, the fifth term in the sequence that is defined by the relation un is equal to u to the un is equal to minus 1 to the n plus 1 times n over 3 n minus 1. And they want the fifth term, so we'll just put n equal 5. And so u5 is equal to minus 1 to the 5 plus 1 is 6. Minus 1 to the 6 is always a positive number 1. So we'll get 1 times, put in n times 5 is 15 minus 1 is 14. And so we get 5/14 is the answer. Too easy, soft. That's question 18. All right, question 19. It says, which of the following converges? There are many ways that as n goes to infinity, it's going to some finite value. All right, so let's check it. So let's use limit laws then to check it. So we're going to check them by finding out the limit as n goes to infinity for each. So an easy way to do that is what I would say is, since we're doing an MCQ, right? You don't even need to write no fancy anything. What you can actually write is something like this. See which one is going. Try when n is a large value, when n is 1000, and see which one of them is going to a constant, right? That's what you can do. 2 to 1000, no, that's going to a huge number, so that clearly cannot converge. -1 to 1000, well, notice that this now is peculiar. It's peculiar in the sense that if you put in n as 5, you're going to get -1. You put in n as 6, you get +1. And so this one is alternating. And so this one is not converging. So those two not converging because we're just trying big numbers. You plug in n in the first one as 1000.
Wait, sir.
Yes, go ahead.
If you say -1 to 1000, I get +1, what does that mean?
Yes, that's what I just said. When you try, you get +1. Very good. But if you try the next number beneath it, which would be 1001, you're going to get -1. So no matter which number you plug in, you're going to get either -1, 1, -1, 1. And so this one is
I
not
like it to
converging.
oscillate.
It's oscillating between -1 and 1. And so it's not converging.
It's oscillating. So if you say -1 over 1000, it is 0.001. I raise that to the -1004. It doesn't exist. So it's
So let's try
divergent to
this
a
one.
boy.
So let's look at the first one. We're saying 1 to the n over 2 to the n. Now look at this. 2 to the 1000. What's 2 to the 1000?
2 to the 1000?
Yeah. That's a big number, don't it?
Big number.
And what's 1 over a big
Infinity.
number? What's 1 over a big number?
It approximates to 0, don't it, sir?
Approximates to 0. So this one is clearly converging.
Mm-hmm.
So that's A. Easy question. So that's how you can do it for a multiple choice. I can use trial and error. But let's say you want to be proficient and you want to use laws that you've learned in the actual classroom. What you can do is show that for any sequence that is converging, then that means that the last term, so that's one way to show that it converges. A second method to show that it converges is that if the sequence converge, then the series also converge. And then you can show that it has a finite sum. So you show that Sn is finite. So those are the two ways you can do it using what we'd have learned in the classroom. All right, but who has time to do that, right? We don't have time to do that. Question 20.
Arithmetic. Number 1 is in it, definitely.
Definitely, number 1 is definitely in it. They ask which of them are arithmetic. Number 1 clearly is arithmetic. So if you put R as 1, you get
It's gonna have a common difference of 3.
Yeah, you get a common difference of 3. You get 10, 13, 16.
16,
Yep.
then
This have a
19 onwards.
this have a common difference of 3. Very good. So that clearly is arithmetic. Once you find that each term have a common difference, then it is arithmetic. This one right here is clearly geometric, right? So don't even need to look at number 2.
Oh, because R, the power of R, sir, it gonna have a common ratio.
It have a common ratio when it's raised to a power. So now all we need to do is check out these two terms. So we need to check if they have a common difference. To check if they have a common difference, let's do it in this one. If you're going to write out this one, you put in the first term.
R
The
equals
first term
1.
would be the log of what?
Log of 2 base 10.
Log of 2, yeah. Once it's base 10, you don't need to write base 10. Just write log 2.
Because log of base 10 is just 1.
Yep, so we need to write
Log
base
of
10.
2.
So we have log 2. The next term would be
Nine.
log 3. Then the next term would be log 4. And so what we need to do is check if it has a common difference. To check it if it has a common difference, we need to check if log 3 minus log 2 is equal to log 4 minus log 3, which is not true. So there is no common difference. So this one is not an AP because we cannot find a common difference. So try it in a calculator.
Neither GP, don't it, sir?
Why? Why you say it is a GP?
No, I'm saying it is neither GP.
It is neither.
Yes, sir.
We'd have to check if I have a common ratio. Yes, it's not a GP either because the log of 3 over 2 is not the log of 4 over 3.
Exactly.
All right, so we're just showing that log 3 minus log 2 is not equal to, it's not equal to log 4 minus log 3. And so therefore 3 is out.
Obviously, it's 1 and 4.
Obviously,
Well,
because the
number
two
4 now?
options there. Yeah, but let's just look at the option now. So if you were to plug in R as 1, you're going to get 1 plus 1 is 2, 3 squared is 9, and so get the log of 9, plus, we'll plug in now R as 2,
2,
2 plus 1, 2 plus
3,
1,
3 cube is 9. No, 3 cube is 27.
3 cube is 27, so get the log of 27. And then let's plug in one more. Plug in 3, we get 3 to the 4 is 81.
81.
Is 81. So what you need to check is that the log of 27 minus log 9, well, the log of 27 minus the log of 9 is the log of 27 over 9. Because by rules of logarithm, when we subtract, we're pretty much
Wait, why
just
are we
dividing
subtracting, sir?
to find the common difference. So we're gonna have to, how you find common difference in a AP?
Okay. I just get it.
Yeah, so to find the, this is the common difference. The common difference is equal to the log of 27 minus the log of 9. And we have to check if that's equal to the log of 81 over 27. 81 over 27, I am positive that's the same.
Sir, the same.
They are the same.
Same.
So therefore, BAT is the answer. All right. So, question 21. Question 21 says that the sum to infinity of a geometric series. So we need to find the sum to infinity. How do we find sum to infinity?
Sum to infinity. That is
That's not what the question is asking, you know, but I'm just asking.
A times 1 minus R to the N.
Repeat.
A over 1 minus R.
A over 1 minus R. But yes, this is the question I'm asking. What, right? And they ask you then, what is the sum to infinity?
So the answer to me is C, you know. Because if it, remember, you know, sir.
No, I know. This question is C. I was just asking a different question. But all right, let's not waste time. So yes, so from this, the common ratio 2x must be between
Between
1 and
-1 and +1.
very good. And so x between a half and negative a half.
Between a half and negative a half.
That looks like cat. Every minute my screen freeze. Give me a second. All right, question 22. Talk to me, what's 22?
The answer
We've done this
is
so many times.
C. A C or D? I think a C. What did you do this again? All right, so we
Question
say
22 is C.
Sn. One answer. Sn is the sum of the first n terms. So it'd be
Sn is
like
the sum of
A1,
first n term. Very good. Sn is
A1 plus A2 plus A3 plus onward up to An.
very
And
good.
then n plus 2, the sum of the first n plus 2 terms.
Very good. So it go from A1, go straight all the way up to An plus 2.
Up to An plus 2. So when you subtract them now, A1, A2, and A3 will cancel out, as well as An going to cancel out as well.
An is going to cancel. And so what is Sn plus 2
Back with
minus
An plus
Sn?
2.
What we left back with?
An plus 2.
An plus 2?
Yes, sir.
Just An plus 2? Just An plus 2? So look at it. If we're going to subtract them, the A1s are going to cancel. Everything
Oh,
will
wait,
cancel up to
wait. A1, An plus 1 and An plus 2.
Very good. So An plus 1
Yeah.
will remain plus An plus 2. An plus 1 and An plus 2 will remain. Easy. Question 23, this is so boring. They ask it on every paper.
Boy.
We just have to remember n choose r is equal to n choose
R is equal to that symbol with n on top and r at the bottom, which is equal to n factorial over n minus r factorial times r factorial, which is also equal to.
So all of what he's saying is just represented by this symbol right here. N choose r, it is also equal to n choose n minus r. You can use the factorial notations and prove this to be true, but just always remember it. N choose r is equal to n choose n minus r. And so n choose 2 is equal to n choose n minus 2. By just remembering that one fact right here, n choose r is equal to n choose n minus r. And so that looks like but. That's question 23. Question 24. Question 24 is asking for the limit as n goes to infinity of the sum. So first we have to do is use method of difference to find what the sum is.
Yes,
Before we
sir.
can evaluate the limit. So let's use method of difference. We'll plug in I equal 1 in the first bracket. We're going to get 1 plus I equal 2. We're going to get a half.
1 plus a half.
And for 1 over I now, we keep plugging in all the values of I up to n. Adding all the values up to n till we get
1
plus
over n.
1 over n.
I will subtract that from
And then we're going to be
half
subtracting.
plus 1/3.
We're going to be
plus
subtracting I equal 1, where you get 1/3. We start with a half first.
a half plus
Then
1/3
1/3. Then we'll go
plus
all
1
the
over n
way
plus 1.
up to, we'll plug in n equal n minus 1. We get 1 over n plus 1 over n plus 1.
N minus.
And so what we notice is that we're going to be left back with 1 from the first bracket, half cancel, everything go up to 1 minus n cancel. Then we're going to have minus 1 over n plus 1. Now look how the question is easy. They're asking for the limit of this thing. As n goes
Wait,
to,
sir.
yeah.
So the 1 over n minus 1 is going to cancel.
The 1 over n.
Oh yeah, the 1 over n is going to cancel.
Yes, 1 over n cancel.
So you're left back with 1 minus 1 over n plus 1. Okay.
1 over 1. 1 minus 1 over n plus 1. But as n goes to infinity now, as n goes to infinity.
Oh, they also want us to take the limit of which n approaches infinity as well.
Yes, so as n goes to infinity, then
n
this part goes to
over n
0.
plus 1.
So it's equal to 1 minus 0. So the answer is 1.
Yeah, yes, sir.
Easy question.
As n approaches infinity, n plus 1 over approach infinity as well. And then 1 over n plus 1 over approximate to 0.
Very good. Easy stuff. Easy stuff. This is a repeat as well. So what's this question? What's this answer?
We get, what do you get again? A.
Apple.
Yes, sir.
Yeah, this is a big repeat. Always repeating. I'm sure it's gonna come back this year. It's gonna repeat. Don't even need to look at that. You repeat too much.
Sir, we got for 24 again. A.
A. Yeah.
C. Oh, A.
Boy, question 24. 24 is C.
24.
C.
C. Okay.
All right. Question 26. Question 26 says, given that the coefficient of the term.
Sir, I skip number 25.
We're gonna skip it. We'll do it last week, we'll do it the week before, we'll do it the week before. All right, so let's just do it then. So question 25 right here, did not skip it. So they're asking for the term that is independent of x.
Over x.
Term that is independent of x mean they're asking for the constant.
Constant.
Right? The constant term is going to be
from equals 0 to n of.
So look at this. If we raise x squared to the 4th power and we raise 1 over x to the 8th power.
Sir, wait. The formula is the sum from r equals 0 to n of n choose r times a to the n minus r times x to the r, right?
Yes, that's the formula. That's when you're evaluating the entire sum, right? You don't need to write out the entire formula. We're just choosing one particular term, right? But the particular term that we're choosing now is a term that is independent of x. This is going to be the term that is independent of x when r is going to be equal to 4, right? And so therefore, what's associated with it is 12 choose 4.
n choose r, so it's going to be 12 choose
and so the value of the term is going to be this. How do I know it's going to be 12 choose 4? Well, x to the 8 times 1 over x to the 8. This part will cancel each other and just work out to be 1. This is going to be worked out to be 12 choose 4 times x to the 8 over x to the 8. And x to the 8 over x to the 8 is just 1. And so that's why it's just 12 choose 4.
The 12.
You're going to have 12 choose 8, you know, but remember we discussed last week that 12 choose 8 is also equal to 12 choose 4. Because we use the formula that tells us that n choose r is equal to n choose n minus r. We just didn't want to get into this question again because we've been doing this question too many times. They repeat it so much, I guarantee that it's going to come this year. I would bet on this question coming. All right, it says, given that the coefficient of the term in b cubed in the binomial expansion is 40, then what is a? So they're giving us the coefficient of b cubed, right? So since they're
a
giving us
plus b to the 5th whole.
so it's to the so we have a squared b cubed, and then that's just going to be 5 choose 2. So 5 choose 2 times a squared b cubed, that's equal to 40b cubed.
Why say 40b cubed, sir?
Because that's what they tell us. They tell us that the coefficient of b, they tell us that the coefficient of b cubed is 40. And so you put a 40 before the b cubed. That's what they said in
a square.
Repeat. So we're trying to find a. So we're trying to find a. So now b cubes are going to cancel from each side. And so what we're left with now is 5 choose 2. What's 5 choose 2?
10.
5 choose 2 is 10. And so what we have now is 10 times a squared is equal to 40. And so a squared is equal to
a squared is 4.
And so a squared is 4. And so a is equal to 2. A squared is 4. And so a is going to be equal to 2. So that looks like.
Practice some more of number 25 questions, sir. You get the gist
more of 25?
Yes, sir.
All right. Nice. Question 27. It's asking us to evaluate the summation. They just give it in a pretty way to say find a. But they're asking you to evaluate the summation. Now look at this. We're summing from 2 to infinity of 2 to the minus n. So 2 to the minus n is really 1 over 2 to the n. Right? So if you're plugging in from 2 first, what you're summing is
1 over 2 to the 2
to the minus 2
the quarter
plus, yeah, let's write that down next. 2 to the minus 2, plug in n equal 3, you have 2 to the minus 3. And we're going to keep doing this, 2 to the minus 4. And we'll do this all the way up to infinity. Right? We're going to do this forever. But we can't do that forever. So let's going to use GP formula. Tell me, how do I know that it's a GP? How do I know that it's a GP?
Because
it has a common ratio.
A common ratio, yeah.
If you work out 2 to the minus 3 and divide it by 2 to the minus 2, it's going to be equal to 2 to the minus 4 divided by 2 to the minus 3.
Oh, yes. No, it's a GP for you, sir. It's a GP for you.
Yes. And it has a common ratio of a half. So if you work this out, it's going to have a common ratio of a half. And so it's pretty much the first term, which is 2 to the minus 2. 2 to the minus 2 is a quarter. So a quarter divided by 1 minus r, and r is a half. So a quarter over 1 minus r. And what's a quarter divided by a half? A quarter and divided by a
times
half.
2, which is
Quarter divided by half is a half?
Yes, sir.
That's true. That just sounds weird to say a quarter divided by a half is half, but that's right. All right. Question 28. Repeat too much. What's question 28?
The McLaren series, this look like
We do this too much time.
A.
Yep, that's A. And I don't know if you remember the formula that I said, nobody tried the homework. I'm positive. But yeah, this is sin x. So we've done that too many times. Easy question. What's 29? 29 is also a repeat. What's 29?
What do I remember this again?
Sir D.
Yes. Delta. Easy. We've done that too many times.
Linear interpolate the first approximation to the root in this interval. So just basically use the interpolation formula.
The interpolation formula, which is A times f of
times
B
f of B
plus B times
f of A divided by f of A plus f of B.
Yes, and remember that we take the modulus of those functional values.
We take the modulus.
Yes, very
We
good.
won't take any negative value in the formula.
All right, question 30 is also a repeat. That's question 30.
Just again, I think it's dog.
You sure?
I'm positive.
Yes.
Yes,
sir.
it is dog. So this is another repeat question. The answer for this one is dog. Easy stuff. Question 31. It says now, in how many ways can the letters A, B, C, D be arranged so that A, B are always together? So think of A, B
and B are always together.
as
So
one
they
letter.
make one unit, and then you have the other three letters, them will form 3 units.
So that's 4 units in total, which is 4 factorial times, we don't have to be in the order A, B, can be in the order B, A. So times it by 2.
So times 2 factorial, which is 2 same way.
So the answer is beta. All right.
And then number 32 is apple.
A.
Question 32 repeats so many times. This has been repeating since the first time paper 1 came. I don't know why they like that question so much.
713.
So that's A. Question 33. They couldn't have given another A, right?
Another repeat?
Yeah,
You're choosing 10 from 15. What's that?
So it says a reading team of 5 teachers is chosen from a group of 15
over 15 minus 5 factorial. So
yeah, because we're just choosing 5 from 15 teachers.
Times r factorial.
Easy.
Oh, combination.
It couldn't be any easier. Question 34.
Combination.
What's question 34?
34.
C. Too easy.
So you add up.
And how we do it again?
No, you just multiply them, sir.
You don't multiply them, you add them. It says that it's mutually exclusive. And mutually exclusive events has no intersection. Once it's exclusive, then this is equal to 0. And if that is equal to 0, then the union is just going to be the probability of x plus the probability of y.
Exclusive. Is they mutually exclusive, sir. They have no
Yeah.
intersection.
There's no intersection. So that's why it's 9/20. Easy. That repeats so much.
Okay.
Question 35.
Number 34, cat.
Question 35. It says the matrix A is a 3x3 matrix with determinant 14.
So the determinant is obviously 14, but we just need to find the adjoint, which is
And they
found
give us the
by
cofactor. Look at,
transforming the matrix.
very good. So we need to transpose this cofactor matrix. Now
Yes,
this
sir.
question has a p ratio of 0.42. 0.42 means that a lot of persons get this wrong in CAPE. You know why? A lot of persons is reading this as A, but they don't finish read the entire question. The entire question says this is the cofactor matrix. So if it's a cofactor matrix, we just need to transpose this to find the adjoint. So transpose it by interchanging the rows and the columns. So we have 4, 3, 1, minus 14, minus 7, 7, minus 2, minus 5, 3. So that is beta.
35 is boy.
All right, so this was the trick part of the question. You have to read it. A lot of persons don't read. They just look at the matrix and start doing everything already. So if a new question come, read the entire question, which I highly doubt. More than likely a new question won't come. I'm just saying.
Oh, this says the answer is 0 because one of them is not a scalar multiple of the other. So
All
it just
right.
basically makes the whole system 0.
Very good, because the system is inconsistent. And because the system is inconsistent, this is the answer, A. Because look at this equation. If we were to multiply this equation by 3, what we would get is that we're going to see that we would get 6x plus 9y plus 6z is equal to negative 15. Now that's not down here. And so clearly this system is inconsistent. And because the system is inconsistent, then it has no solution.
Sir, so what if all of them were inconsistent, sir? Like all 3 of them were scalar multiple or scalar multiples of each other.
If all of them are scalar multiple of each other, so let's say this was equal to negative 15, then this would have infinitely many solutions. That's what would happen. It would have infinitely many solutions. Just look at it. So let's even use a simpler example. X plus y plus z equal 3. Then it said 2x plus 2y plus 2z is equal to 6. And then let's say 3x plus 3y plus 3z equal 9. This system is then consistent because if you multiply this equation throughout by 2, you get 6. If you multiply this system throughout by 3, you get 9. So no matter if you solve these 3 simultaneously together, you'll be able to get a solution. So this is consistent. All right, now this over here is inconsistent because when we multiply this one by 3, we're not getting negative 16. So you can't solve them together because imagine it this way. How can I tell you that the sum of these 3 things together equal negative 15 times it by 3? You're getting it that it's equal to, you're getting that 6x plus 9y minus 6z is equal to negative 15. That's what you're getting. And then how can I tell you that these same three things, when you add them together, are negative 16? These two don't make no sense, because let's say you were to equate this and this. Equating them together, then you're pretty much getting that negative 15 is equal to negative 16. That don't make no sense, which is never true, and so it's inconsistent. It doesn't make any sense. Question 17 is a 37 is a repeat. What's question 37?
Element 3, then the cofactor of the element 3 in M, which is the 4, right?
Yes.
So it's going to be 3, 2. So it's plus 3, 2.
A,
No.
sir.
It's A. What are you looking at? So how you should do it is just make a cross for the row and the column where 3 is in, and say get 1, 4, 0,
Oh,
5.
element 3.
Sir,
Oh,
sir, not
Yeah.
A, sir. I negative 1, sir.
Negative, sorry. Thank you.
plus, minus, plus, minus. Yeah, boy.
Don't
Yeah,
give it
boy.
away, don't give it away, don't give it away. So that's B.
This 36 is what again, sir?
36 A.
Oh, I never recorded it.
All right. Question 38. Question 38 gives us that P times Q is 21I. And they want to find, this is a repeat. What's this question? What's this answer? They want P inverse.
P
B,
inverse.
So what's the answer?
dog.
Dog. Very good. Very good. Now, don't be shocked if they repeat this question but ask you for Q inverse.
Q inverse is 1 over 21p.
1 over 21p. Very good. Very good.
So when I multiply 1 over 21, I times it by Q. That's going to give a P inverse.
Exactly. Question 39. Question 39 says the letters of the word irregular are to be arranged in a line. The number of possible arrangements in which the three R's are not together. This is a repeat. What's question 39?
When they're
B.
not together.
What's question 39?
B, sir.
B?
Yes, sir.
You sure?
Yes, sir.
9 dog.
It's actually
No.
dog.
Oh, no, sir.
All right, so let's look at why now. So it says the letters of the word irregular arranged in a line. So let's look at the possible ways that the R's are together. The possible ways of the R's are together. There are 3 R's. And so we have 9 letters. And so the possible ways of R's
9
together
letters,
is
9 factorial.
These R's, think of them as one
They
letter.
form 1 unit, sir.
They form 1 letter. And we have 1, 2, 3, 4, 5, 6 other letters. So 6 plus 1 is 7 factorial.
7 factorial.
But then these 3 R's can be arranged in 3 factorial ways. So this would be the number of ways that the R's are together. So RT stands for R together. So now they want the number of ways R's are not together. The number of ways for R not together, I'm going to write it as RT complement. RT complement is going to be the total ways of arranging this word, which would be 9 factorial minus the number of ways R's are together, which is 7 factorial times 3 factorial.
To get when they're not together, sir, it's the total of when they're together minus the total of all of the letters minus when the R's are together, right?
Yes, that's how you find it. So think about it naturally, right? The total number of ways to find out if something not happened is a total possibility minus the number of ways of it happening. So in general, the total number of ways to find out for R's not together is the total number of ways to arrange the word minus the total number of ways R's are together. All right. So it's just like this. What if I ask you the total number of ways of obtaining a 6 on a die? It's the same thing as the total possibility 6 minus the number of ways of not getting a 6, which would be 5. 6 minus 5 is 1. Now notice that you could have just looked on it and say, yeah, there's only one way to get 6 on a die. But it's also the total possibility minus not getting a 6. And likewise, if I ask you for the total possibility of not getting a 6, it's 5, which would just be the total number of possibilities minus the number of ways of getting a 6. So just to make that clear, the number of ways of finding where R is together is the total possibilities minus the number of ways R is together. And this, by the way, is a colon right here. This should be a colon. Why look like this? RT colon. So that's delta. Question 40 is a big repeat. What's question 40? What's question 40?
C.
C, very good. It is indeed C. So it is just the probability of obtaining a head, as well as getting a number that is less than 4, and we just multiply them out. Probability of getting a head is a half, times probability of getting a head is a half, times getting a number that is less than 4 is 3 over 6, and so we get 1 over 8. Nice. All right. Question 41. This is another repeat. What's question 41?
D as in dog.
D as in delta, dog, whatever. You name it. Question 41 is dog. Right, so we've done this so many times. So that's question 41. All right, question 42. What's question 42? We've done this a couple of times. It says if the auxiliary equation for the homogeneous second order differential equation is a real constant coefficient given by lambda squared plus 6 lambda plus 50, then what is the general solution of the differential equation? We did this already. What's the answer? So this one is dog as well. Let's refresh our memory how we got dog. So first and foremost, we notice that we're solving lambda squared plus 6 lambda plus 50. And we set that equal to 0. That's what we're solving. That's the auxiliary equation. Now notice that if we solve this auxiliary equation, right, first and foremost, to solve it, we're going to have lambda is equal to minus b plus or minus the square root of b squared minus 4ac over 2a, which is 6 squared minus 4ac over 2a, which is 2 times 1, which is 2. Now this is going to give us a complex number. So we're going to get a complex solution. So lambda is minus 6 plus or minus 36 minus 200 is some negative number. So it is some negative number. I'm going to call it a, square root a times I over 2. But remember that when the solution is complex, then the general solution is going to be of the form y is equal to e to the px times a cos qx plus b sine qx. That's when the solution is complex. That's when you solve your auxiliary equation. So whenever you solve your auxiliary equation and you get that lambda is equal to p plus or minus qi, then this is the general solution. So that is dog. What's question 43?
Sir, I'm sorry about that. My light went out and came back.
Okay. We're looking at question 43. What's question 43?
B,
Sir,
sir.
can I get number 40 and 41, please? I see the question.
Okay, give me a second. 40.
40 and 41.
40 is C and 41 is 40 is C and 41
41 dog.
All right. Go again. What's 43?
42 now. Or all I do is just find the roots of the auxiliary equation.
Yes, and it was complex, and so we get a complex solution.
Okay.
43. So we're saying it is B. Let's see if it is B. So we have x minus 2 dy by dx is equal to y. So there are two ways to do this differential equation. So let's
You can use
see.
separation of variables, right?
We can use separation of variables. So we have x minus 2 dy by dx is equal to y.
Yes.
All right, so now what I'm going to do is I'm going to bring dx over here. And so I'm bring y over here. So I'm going to get 1 over y dy is equal to, bring dx up there, then I'm getting 1 over x minus 2 dx. So I group the x with dx on one side, and I group the y and dy on the other. Right? So you agree with this step, right?
Both sides.
And then we integrate both sides now. Or integrate 1 over y, we get ln y, and that's equal to ln x minus 2. But when you integrate, you always add a constant of integration. This constant, I'm going to call it ln c. Since everything is with logs, I'm going to call this constant ln c. Now, by laws of logarithm, the log of a plus the log of b is the log of ab. So this works out to be the log of cx minus 2c. And that's ln y. And so what I'm getting then is that if I raise this, if I put e raised to this power and e raised to this power, e cancel ln. And so what I'm getting is that y
equals to cx minus 2c.
Y is equal to cx minus 2c. You can factor out back that constant. And so y is equal to c times x minus 2. So y is a constant times x minus 2.
So.
But they don't have none of those options. But look how this is easy now. Look at this. Look at this now. They don't have none of these options, right? Now I can tell you that this e to the ln is equal to ln e. They're both equal to 1. Why am I telling you this? It's because it implies that
E to the ln of 1 is e to the 1, which
so what I'm
is
actually saying is e to the ln c, e to the ln c, follow me carefully, e to the ln c is just c.
a constant, yeah.
And then times e to the ln x minus 2 is just x minus 2. You agree?
Yes, sir.
So right here, this part y now can be rewritten as e to the ln c times e to the ln x minus 2. That's method 1 of doing it. Method 2 now is to use first order. So we can use first order from right here by getting it in its standard form, dy by dx plus
y prime plus py.
Yes, but that's long to do right now. So yes, as we rightfully said, it is beta.
Oh, beta.
Yeah. Question 44. Question 44 is a repeat.
Given that y equals to pi by 4 and x
and
equals
x equal to a half, then the particular solution of dy by dx is equal to 2x cos square y. So first and foremost, it's the same thing. Bring the y's on one side, so we get 1 over cos square y.
So you have dy by dx.
1 over cos square y dy is equal to 2x dx. And then what's the integral of 1 over cos square? We're integrating sec square. So integrate cos square,
Tan.
we get tan. So we get tan x is equal to integrate 2x, we get
Tan
x.
y, sir.
Sir, tan y precisely.
Thank you, thank you. So use the integrating with x.
Plus d.
So we get tan y is equal to x squared plus c. We don't even need to go no further because only one of them have tan y equal x squared. That's A. Easy question, soft. Now look at this. 1, 2, 3 question we had.
But sir, remember, you know, them say when x equals to a half and y equals to pi by 4.
Yes, but
so
I'm
it'll
saying
be a half square.
I'm saying we don't need to. I'm saying that we can stop right here because you know that it's tan y equal x squared plus c. You don't need to find the constant c because there's only one option with tan y and x squared. And so even if you find c, it's just going to be equal to 3/4. You get what I'm saying?
Yes, sir.
Yes, sir.
Yeah, I'm saying that if you don't need to waste time, you don't need, but let's say you finish, like let's say you're done now, you're done, right? You're done. Right, so Shine, you're done too, you're done the paper, right? And you know enough people are gonna get bills. And you want to make sure, say, them see all they're working out. So when them differentiating the top students, you want to make sure say all they're working steady. So you go back now when you're done, you finish it and you find C. Right? But in general, you don't need to find C, given that only one option at it like this. All right, question 45. Same question again. All you have to do is group x's on one side and group y's on one side. So we have 1 over y dy is equal to 1 over x dx.
integrating both sides.
Integrate both sides again.
is
ln
equal
y.
to the ln of x plus the ln of c.
All right, very good. Plus the ln of c. Since them use k this time, let's use k, the ln of k. The ln of k.
Yes, sir.
And so now, therefore, y is equal to, now we'll bring these together as one ln. It's ln x times k, and so y is equal to k.
ln of kx.
Yep, y is equal to kx. Easy question. So,
Sir,
Oh,
yeah,
since it's everything is in ln, sir, we can just remove the ln's and then just say y equals to k times x.
yes, because you're going to get ln y is equal to ln kx. Yes, Ticia, go ahead.
um, so sir, number 39. Could you,
13.
yes, sir, could you please go over that again? Because uh
All
the
right.
answer that I got was B. Well, not I got that the answer she got.
Wait, sir, why you get y equals to kx?
Yeah. All right. So
And
the
that's
answer
option
is,
or boy?
yeah. So the answer is dog, right? So sometime in the answer sheets, when they type it up, sometimes there's a typographical error. That happens a lot of time. But let's go back to this one, right?
Yes.
Let's go through that one. So I'm going to start with, just for example, I'm going to use A, B, C. A, B, C. I'm going to use something simple. A, B, C, D. So there's a 4-letter word, right? And let's say I ask you from this, I ask you to find the number of ways where A and B are not together. Number of ways A and B are not together. Number of ways A and B are not together, right? The number of ways A and B is not together is equal to the total arrangement minus the number of ways, total arrangement minus the number of ways A and B are together, minus A and B together. And why is that so? That is so, this formula is true because think about it this way, the total arrangement is going to be the number of ways A together and the number of ways A are not together. All right? Think about it this way. So I'm going to call total arrangement TA. Right? In general, TA, if you were to make TA the subject, total arrangement would just be the number of ways A and B are together plus the number of ways A and B are not together. Right? Think about it. From set theory, they would tell us that A union A complement. What's A union A complement? That's equal to the sample space, which is the total possible arrangements. A union A complement is equal to sample space. So back to the question now. So this question where I'm asking you for the number of ways A and B are not together. The number of ways for A and B to not be together is total arrangements. First and foremost, the total arrangement is that there's 4 letters, so the total arrangement is 4 factorial. So in this case, number of ways A and B not together, number of ways, taking too long, number of ways A and B not together is equal to 4 factorial, so it's equal to 4 factorial minus the number of ways A and B together. Now the number of ways A and B together, number of ways A and B being together would be, A and B being together would be, A and B is like one item now, so it's 3 factorial times 2. And so the number of ways of A and B not being together is going to be 4 factorial minus 3 factorial times 2. So this works out to be 4 factorial, which is 24, minus 3 factorial times 2 is 12. 24 minus 12 is 12. Now, this is using the formula. Now, look what I'm going to do. I'm actually going to just write them out. I'm going to write out the 24 ways in less than a minute real quickly for A, B, C, D. Write out all the possible arrangements. So there are 24 possible arrangements. Let's write them down. Starting with A, we can have A, B, C, D. We can have A, C, D, B. We can have A, wait, A, B. Let's go in order. A, B, D, C. We can have A, C, B, D. We can have A, C, D, B. We can have A, D, B, then C. And we can have A, D, then C, then B. You agree with all of these? Agree with these groupings? That's when A was starting with A. We agree with this? These are the total arrangement with A. Notice there is 6. 6 of them. There are going to be 6 total arrangements starting with B as well. So if we were to start with B, we can have BA, then CD, or we can have BA, then DC, or we can have B, then C, then B, then C, then AD, or we can have B, then C, then DA, or we can have B, then D, then AC, or we can have B, then D, then CA. Agree with these 6? Tisa, hear me? Agree with these 6?
Yes, sir, I'm hearing you. Yes,
Okay. All right, so tell me the 6 that it would be if we start with 3. If we start with C now, so this is starting with A, this is starting with A, this is starting with B, this is then starting with C. What would it be? Tell me the 6 ways starting with C. Who could arrange the word?
C-A-B-D.
So it says C-A-B-D, yeah? Then C-A-D-B, then
CBAD.
C-B-A-D, then C-B-D-A, then which 2?
C-B.
C-D,
B-A.
D-A, then C-D-A,
A-B.
A-B. All right, so you get all 6 of them now. I'm just going to do the same for D real quickly now. So let's do the same for D. So with D now we can have DA, DC, or we can have DA, CB, or we can have DC, AB, we can have DC, BA, we can have D, let's say DB, AC, or we have DB, CA. So this is the 4 factorial. Now look at it. You say it work out to be 4 factorial. It is true. The formula method that they teach us, it is true. So this is by working them out by hand. So the total possibilities is indeed equal to 24. Now the question we were asking is find the number of ways A and B not together. Now A and B not being together, now right, let's just underline them here in red when they're not together. They are together here, not together, AB not together, not together, not together. So that's 4 times they're not together from the first set. AB not together, that's where we're looking for. Right here, AB is together there, AB is together here. Not together, not together, not together, not together. AB together here, not together, AB is together here, not together, AB is together here, AB is together here, AB is together here, not together, AB is together here, AB is together here, AB is together here, not together. Now adding this is 1 plus 2 plus 3 plus 4, 5, 6, 7, 8, 9, 10, 11, 12. So the total number of ways AB is not together is 12. Now look at it, that's the same 12 we got right here. Now AB not together is just a simple formula. It is the total arrangements, which would be the 4 factorial minus the AB being together. All right, so this is just how we get that they're the same, right? They just came up with a formula to represent all of this, because what if there are 35 letters? No, they don't have so much letters. Yeah, what if there are 25 letters being used, right? Then what we're gonna have to do is we cannot be writing out so many different possibilities. So that's where the formula came in. And this is the formula, the number of ways for 2 letters to not be together or 3 letters to not be together is the total arrangement minus the number of ways the 2 letters are together. And so let's look at it. Go back to the question now. So the total number of arrangements, arrange the word irregular, is indeed 9 factorial. So now we just need to subtract the total number of ways of the R's being together. The total number of ways the R's being together is, if you were to rewrite the word irregular without the R's being together, so you have I, E, U, G, L, and then you have R, R, R. I feel like I left out a letter. A. Right? So this is still 9 letter, but all of this now, all of this is 1, 2, 3, 4, 5, 6 letter. The R's being together are like 1 letter, so in total that's 7. So it's now 7 factorial, but then you have to times it by 3 factorial, because these 2 R don't have to be together. It could have been this R and this R, they're right here. So, or this R, they're right here. So, and so the number of ways of arranging these 3 R's is 3 factorial. And so that's why it is now 9 factorial minus 7 factorial times 3 factorial. So that's clear now? That's a little better?
Yes, sir, I guess.
You guess? Why you say you guess? You don't sound like you're fully convinced.
Sir, normal. Yes, sir. Yes, sir.
Yeah, what were you saying normally?
When I thought like when you have 3 of the same thing, they would like divide by 3. Why didn't they do that in this question?
Why didn't divide by the 3?
Like if you have 3 of the same things, right? They
Yeah.
would normally divide by, is that the repetition method? I think.
Oh, that, no. I get what you're saying now. I get what you're saying. That method now, that's, for example, let's go back to the question, what they were asking. So this question is what you're looking at, the number of distinct permutation of the letters of the word possibility. Now this question is asking you for the number of ways how we can write the word possibility, but it was not asking you for the number of ways for the S's to be together, the number of ways for the I's to be together. Right? So you notice the difference between these two questions?
Yes, sir.
So that's why. So when you're doing permutations with repetition and restrictions, then this is what we have to consider. Now this question around here was just asking us arrangements when some letters are not together. So that's the restriction right here.
Okay, sir. Thank you.
Yeah, so that's repetition and this one is restriction. And that's 2015. So let's have a look at 2016 now. Don't worry, we're going to finish 2016 in no time. And the reason being, a lot of these questions are repeated. For example, question 1. Question 1 is what?